So this is the video lecture for section 4.5, applied calc, MAC 2233. So this is the derivative of logarithmic functions. So the first one is that if y is equal to log base a of x, then y prime is equal to 1 over x times the natural log of a. A, of course, is a constant. Second rule, if y is equal to the natural log of x, then y prime would be 1 over x. The third rule, basically the same as the first one, but if the log base a of the absolute value of x, then y prime is also 1 over x times the natural log of x. The next one says that if y is equal to log base a of the absolute value of g of x being the function, then y prime is equal to g prime divided by natural log of a times the original function g of x. And then the next one here is just a repetition of the first one. If y is equal to the natural log of the absolute value of x, then y prime is 1 over x. And then the last one, if y is equal to the natural log of the absolute value of g of x, then y prime would be g prime over g of x. So if we look at number 8, here, what we can do is we can separate these, right? So then y is going to be equal to the natural log of x of 8 plus the natural log of x. And then, of course, y prime then, so if we have the natural log of 8, that's just going to be 0. And then the natural log of, that's y prime. The natural log of 1 over x is just, the natural log of x is just 1 over x. So then y prime for this one would just be 1 over x. The next one is number 4. So number 4 here we have the natural log of 1 plus x to the third power. So if we define g of x to be 1 plus x to the third power, then g prime of x would be 3x squared over 1 plus x to the third power. And so that is in fact the answer. So g prime would be 3x squared plus, 3x squared divided by 1 plus x to the third power. So the next one that we're going to do is number 8. So number 8 here, what I'm going to do is I'm going to rewrite number 8. And this one's going to be the natural log of 2x plus 1 raised to the 1/2, right? And so here in this case, of course, we're going to say that g of x is going to be equal to 2x plus 1 raised to the 1/2. So we're going to use the chain rule for this one. So then g prime of x is going to be equal to 1/2 2x plus 1 raised to the negative 1/2. And then, of course, times 2. And then, of course, 2 times 1/2 is just 1. So therefore, this becomes 2x plus 1 raised to the negative 1/2. And remember, since this is the natural log of g of x, right? So if y is equal to the natural log of g of x, then y prime will just be g prime of x over g of x. And so in this case here, since we have the g prime, so the g prime is going to be, so y prime is going to be 2x plus 1 raised to the negative 1/2 all over 2x plus 1 raised to the 1/2. And so what this is going to end up being is going to be 1 over 2x plus 1. So negative 1/2 minus 1/2 is negative 1, and then we write it as with a positive exponent, so it'll just be 1 over 2x plus 1 to the first power, which is just the way that we have it there. So for number 12, we're going to have to use the product rule. So we have 3x plus 7 times the natural log of 2x plus 1. So then if I make this u and this v, I can define u prime to be 3. And then v prime is just going to be 2 over 2x minus 1. So it's going to be g prime, which is 2, over g of x, which is 2x minus 1. And so therefore, y prime then is going to be 3x plus 7 times 2 over 2x minus 1 plus the natural log of 2x minus 1 times 3. And so we can kind of clean this up a little bit, which will be 2 times 3x plus 7 over 2x minus 1 plus 3 natural log of 2x minus 1. And we can leave it like that. There's no need to go any further with that one. So number 14, we're going to use the product rule again. So we're going to define this to be u. This one here is going to be v. So u prime is 1. And then v prime is going to be negative 2x over 2 minus x squared, right? So it's just going to be basically just the g prime, which is negative 2x, and then the g of x, which is 2 minus x squared. So then y prime is going to be x times negative 2x, 2 minus x squared, plus here we're going to have the natural log of the absolute value of natural log of the absolute value of 2 minus x squared. And so when we end up doing it, we can just multiply the x times the top, so it's negative 2x squared minus 2 over 2 minus x squared plus the natural log of 2 absolute value of 2 minus x squared. So that's how we do number 14. Now number 18, we're going to go ahead and use the quotient rule. All right, so if I define u to be negative 2 natural log of x, then u prime would be negative 2 over x, right? Because I can get rid of the constant for a second. The derivative of natural log of x is 1 over x, and then multiply the times the 1 over x. So v would be 3x minus 1, which makes v prime equal to 3. So then y prime is going to be 3x minus 1 times negative 2 over x, right? And then it's going to be minus, so negative 2 natural log of x times 3, all over 3x minus 1 to the second power. And so if we clean this up a little bit, it's going to be negative 2 3x minus 1 over x plus 6 natural log of x all over 3x minus 1 to the second power. Now if I multiply everything by x in order to get just one fraction, just a simple fraction, then it's going to be negative 2 times 3x minus 1 all over x plus 6x natural log of x over x, and then x times 3x minus 1 to the second power. So I can clean this one just a little bit more. So, sorry, not that x. And so this is going to be basically negative 2 3x minus 1 plus 6x natural log of x over x 3x minus 1 to the second power. And then of course I can go ahead and finish it off, which is going to be negative 2 3x minus 1. I need to put the minus 1 there, plus 6x natural log of x over x 3x minus 1 to the second power. And so that's how we end up with the answer for number 18. So number 22, we have y is equal to the natural log of the absolute value of x minus 3. So we can write this one as like that. So which means that we can go ahead and just do the power rule, right? So then u would be my x to the 1/2. U prime would be 1/2 times u raised to the negative 1/2. And then my v would be the natural log of x minus 3. And so v prime would be 1 over x minus 3, right? So the derivative of x minus 3 is just 1. So then y prime, then in this case, would be 1/2 natural log of absolute value of x minus 3, right? Times the derivative, or times the original, times the derivative of natural log of x minus 3, which is 1 over x minus 3, which ends up being, since this is a negative 1/2, so then this ends up being 1 over 2 x minus 3 natural log of the absolute value of x minus 3 to the 1/2. And so that's how you do number 22. All right. Let's go to number 24. So I'm going to say this is u and this is v. Let me just put this line here. So u is the natural log of 4, so u prime is going to be 0 because that's a constant, right? If v is the natural log of the absolute value of 3x, then v prime will just be 3 over 3x. And so this will just be 1 over x, right? Because we can cancel out the 3's. So then y prime, right, it's going to be basically, I can do natural log of the absolute value of 3x times 0 plus, in this case, we're going to have natural log of 4 times 1 over x. And so this is just going to end up being the natural log of 4 over x. And that's how you do number 24. Because the first term here cancels out with the 0, right? It becomes 0. So the next one is number 28. And so for number 28, again, we're going to use the quotient rule. So u is the natural log of y. So u prime is 1 over y, right? Because it's just the natural log of a function, which is the derivative of the function over the function itself, right? The inside function, the g of x. And v is e to the y power, so v prime basically just becomes, it's just going to be the natural log, it's just going to be e to the y. Because the derivative of y is 1, so it's 1 times e raised to the e power. So then p prime of y is going to be e to the y power times 1 over y minus the natural log of y times e to the y all over e to the y power squared. And so the next thing that we're going to do is we're going to put this together, right? Kind of clean it up as much as we can. So I can have e to the y over y. Let me fix the equal sign here real quick. Minus natural log of y e to the y over e to the y squared. And so what I'm going to do here is multiply everything by y. So I'm going to have e to the y over y minus y natural log of y e to the y over y. And then in this case here, I'm going to keep it as e to the y squared. And so I'm going to leave this one as extra credit for you guys here so I don't run out of space, basically. So then, of course, we're going to end up with e to the y minus y natural log of y e to the y over y e to the y to the second power. And then, of course, we can go ahead and say I'm going to take out an e to the y, which is going to be 1 minus y natural log of y over y e to the y to the second power. And then if I cancel out e to the y, I'm going to end up with 1 minus y natural log of y, and then y e to the y power. And that's how you do number 28. All right, number 38. Here we have y is equal to the to the log base 2 of 2x squared minus x raised to the 5th power. So we're going to say is that g of x is going to be 2x squared minus x raised to the 5 over 2 second power. And so this is just going to be the chain rule. So then it's going to be g prime is going to be 5 over 2, 2x squared minus x. And then this one is going to be 3 over 2 times 4x minus 1. And so since we have a constant, and the constant here is going to be the base, right? So the base 2, so it's going to be the natural log. So then y prime is going to be 1 over the natural log of 2 times, it's going to be g prime over g of x. So it's going to be 5 over 2, 2x squared minus x raised to the 3 halves times 4x minus 1 all over 2x squared minus x raised to the 5 halves. And so basically here we can cancel out a 2x squared minus x. So then we're going to end up with the following. So it's going to be 5 and then 4x minus 1. We're going to cancel out. So remember, if I do 3 halves minus 5 halves, it's going to be negative 2 over 2, which is negative 1, which means I'm going to put it in the bottom and in the denominator, and it's going to be a positive exponent. So it's going to be natural log of 2 times 2x squared minus x. And so that would be the derivative of number 38. All right. Number 42 is going to be similar, right? So here we're going to say that g of x is equal to x times e raised to the square root of x plus 2. And so g prime of x is basically going to be e raised to the square root of x over 2 times square root of x plus 2. And so when we put it together, it's going to be g prime over g of x, right? So then it's just going to be, so f prime of x is going to be e raised to the square root of x times square root of x plus 2 over 2 over x e square root of x plus 2. And so we can clean this up a little bit. So then this is going to be e to the square root of x, square root of x plus 2, all over 2x e square root of x plus 2. And so that's just a matter of just kind of cleaning this up here. Let me put the parentheses here. And so that'll be f prime. So let's look at number 57. Number 57 is a word problem. And so let's see. So number 57, let me get to the textbook here real quick so I can read it. So it says, suppose that the demand function for q units of a certain item is p is equal to d of q, which is equal to 100 plus 50 over natural log of q, right? So that's the function that they gave us. So d of q, which is p, which is the price function, is equal to 100 plus 50 over the natural log of q. And in this case, q has to be greater than 1, where p is in p dollars, or in dollars. So A says find the marginal revenue. So remember that R of Q is equal to quantity times price. So we have the P, but we have to multiply that times Q, which becomes 100Q plus 50Q over the natural log of Q. And so if I find the derivative of that is going to be, right, so d prime of Q is going to be 100, and in this case it's going to be 50 natural log of Q minus 50Q over Q all over the natural log of Q to the second power. So we can clean up d prime a little bit, right? So we can say this is going to be 100 plus, in this case it can be 50 times natural log of Q minus 1, because the Q's are going to cancel each other out there, and then this is going to be natural log of Q to the second power. So here, right here, when I put that together, the Q's are going to cancel out, which will just be 1 over Q. So if I take out a 50, it's just going to be natural log of Q basically minus 1, because Q over Q is just 1. So that's going to be A. Now, so for part B, they're asking us to find approximate the revenue from one more unit when 8 units are sold. So basically what we're going to do is we're going to find d prime of 8, and d prime of 8 is going to be 100 plus 50 natural log of 8 minus 1 over natural log of 8 to the second power, which is going to be 112.48. This is going to $112.48. And then part C says how my manager uses information, so they can use it to decide if it's reasonable to sell additional items after 8 items. All right, that's 57. Let's look at number 58. Number 58, it says if the cost function in dollars for Q units of the item in exercise 57 is C of Q, so number 57 is C of Q is equal to 100Q plus 100. It says find the following. Find the marginal cost, right? So we know then here that C prime of Q is just going to be 100, isn't it? And then it also says find the profit function. So basically it's going to be 100. So P prime of Q is going to be 100 plus 50 natural log of Q minus 1 over natural log of Q to the second power minus 100. And so when we put those together, then actually, let me see, it says find the profit function. Sorry, let me find the profit function first. So let me do that one again, and then I find the revenue function. So then this is going to be 100Q plus 50Q over the natural log of Q minus 100Q minus 100, right? So this is going to be P of Q right here. And so I can clean this up a little bit, which will be 50Q minus the natural log of Q minus 100. And so that's going to be the profit function. And so for part C, it says find the approximate profit from one more unit when 8 units are sold. So then we're going to find, I think it's for C. So this is A, this is B, and this is C. So then C is going to be P prime of Q, which we already have D of Q, which is going to be 100 plus 50 natural log of q. Oops, sorry, let me write that here a little better. Minus 1 over natural log of q to the second power minus 100, which is just going to be 50 natural log of q minus 1 over natural log of q to the second power. So therefore, p prime of 8 is going to be 50 natural log of 8 minus 1 over natural log of 8 to the second power, which is going to give me 12.48. So it's going to be $12.48. So if you sell one more unit after 8 units, you're going to get marginal profit basically of $12.48. So then part D, it says the manager can just use this information to decide whether it's profitable to make and sell additional items after 8. All right, let's look at number 59. So number 59, it says suppose the cost to make XOB reads oboe reads is given by C of X. So number 59. Oh, we did 58, yeah. Actually 57, this is 58 here, so 59. So C of X to make oboe read is 5 natural log base 2 of X plus 10. Find the marginal average cost when the following numbers of reads is sold. So for number 59, we're gonna go ahead and find C bar of X. C bar of X is going to be 5 log base 2 of X plus 10 divided by X. C bar prime of X is just going to be, when we put all this together, it's going to be 5 minus the natural log of 2 and then it's going to be times 5 log base 2 of X plus 10 all over X squared natural log of 2. So so basically, if you just find the derivative of this function, this is what you're going to end up with. So then C bar prime of 10, we're going to plug in the 10, and we get about negative 0.19, and then this is going to be A, this is going to be B, so C bar prime of 20 is equal about negative 0.06, and so then that's number 50, that's number 59 there. So last one is number 60, and so what I'm going to do is I'm going to give you 60 as extra credit. And that's the end of 4.5, and that's the end of chapter 4. Thank you.